So hi all. So today let us see what is the concept of service mesh we going to use in Kubernetes. So while deploying the microservices here. So this is the agenda of this session. So we'll understand what is microservice and what are the key components. So major um, components of having the service mesh and the core feature and benefit of using the service mesh and popular service mesh implementations tools. Along with that, we'll come across some scenario based examples. Okay. So before we get into what is service mesh, so let us understand what is microservices initially. So anyway, we have already come across different components of deploying the applications, right? Whether it could be that is a physical medium of physical servers or the virtual machines. Thereafter, the containerization that is implemented using the Dockers. So to overcome the issues, whatever the Docker wants, we have introduced with Kubernetes, that is pods having the containers, right? So in containers also, that is in Kubernetes pod containers also, we are having some quite issues. It's not something like an issue, um, but it's needs to be pay attention to do all the configurations. To overcome that, we gonna implement the concept of service mesh using the tool. Okay, so we will have some tool. So this is quite a basic introductory about the using of service mesh. So now let us understand what is microservice. So let us understand that we have a Flipkart application and it's not a piece of application, right? So there are n number of components are merged to form a big e-commerce platform or the application, right? So for example, the login is one component, the sign up is another component. So adding address is another component, making payment is another component. So looking for products is another component, that is the search bar, and the slides what moves in your UI or which promotes offers and all. Those are all the different components. In components, can I say it as a microservice? That is, in whole application, the login is one service. I make it as micro in the sense it's a small service like that, right? And when it comes to sign up, it is also kind of microservice. So each each individual service, we call it as a microservice. And once we merge all together, we'll be getting the whole software, right? So this just understanding about what is microservice. Okay. So we'll now understand. So what is service mesh? So service mesh is an architectural pattern that manages communication between the microservices. So while using the microservices, for example, assume that whatever the pods we run in the Kubernetes clusters or in Kubernetes, inside the pod, we will have a many kind of containers, right? So for example, assume that the container one wants login, the container two has uh, the sign up one, or the container three has the search one, container four has this kind, like searching login card and payments account, like that. So all the containers will have different microservices. So if before implementing these microservices, what it was used to means, so I need to set up each individual container with network mapping. That is, whenever the request arises using API gateway, I need to map that, right? So my microservice I having that is running in this container. So once if I click on the sign up button, it should be redirected to that particular microservices. And simply if I hit sign up and it moves to respective microservices means well and good. So if somebody tried to gain access to the data, whatever the data is moving through the sign up microservices, so we need to provide security to that container, right? So additionally, I need to do that. That is, I need to write a script for security and one for load balancing, many things, right? So those will be taken care by the feature of service mesh using some tools. We're going to see those things in future slides. So that is what they are saying. So it takes complete manages communications between the microservices. So the microservices itself will going to communicate to each other. Okay. So in the cloud native application, only the cloud native application. So it provides a way to handle the complexities of service to service interaction. So we will be having the complexity, right? So by linking one service to the another service, and it should be redirected to that one. So instead of writing scripts for all these things, we will be using the service mesh features. Okay, and in a service to service interaction, so such as discovery, we're going to see all these things. And we have already understood why do we require load balance and what is load balancer, right? And failure recovery is nothing but once your pod cross crashed, automatically it should create another one like that, right? And the metrics monitoring without requiring the changes just to the application code. So it's not required to made any changes or to integrate all these code to do this work. So it's not required. Only if I have the concept of service mesh in my Kubernetes, so everything will be taken care by that. Okay, so monitoring logs and keeping the metrics, that is the usage, everything. Okay, so we will have two kinds in service mesh. That is, one is one who going to plan the data, and once the plan have been made, someone needs to instruct, right? So we should have the control like that. So what the data plan is going to do is this consists of lightweight proxies. So we will have another container that wants lightweight proxy. So what is proxy? Here we will be using the sidecar. That is, it's a tool actually, or the software that is going to implement the sidecar. That is proxy that intercepts and manages the traffic between the services. So it will take care of doing all the procedures like managing traffic between the services. So each service instance typically has the corresponding sidecar proxy that handles the communication. So what they are telling me is, so if you have a login or the sign up microservices running in the container, that container is associated with the proxy container. So if you want to interact with that sign up container, you won't be allowed to directly interact with that sign up container. So you need to communicate with this sidecar proxy. So the sidecar proxy will going to redirect your request to that particular sign up container. So we are not allowed to directly communicate with the, it's a kind of a agent. So by integrating the sidecar proxy to each and every container, we can maintain the integrity as well as the security of that container, so without losing any of the bridges in between, and it will take care of complete communication. So like that. Okay, so next is control plan. So this is responsible for managing and configuring the data plans, so how it should go and from where to where it should travel, like that. It connect matrix, manages service discovery, and it provides policies for traffic management. It's a kind of firewall, I can say that. So it is responsible for managing and configuring the data plan. So here we have a writer, so that is whatever the request I send for. So if I click on the sign up button or the Flipkart web applications or the mobile applications, so I'm going to decide so from where it should travel and where is my microservices sign up is running and where the data should be traveled, everything. So the complete matrix manages service discovery and provides policy for traffic management, so how it should travel, like that. Okay, And we have some very core features that why we should only use service mesh, why not the other things like that. So it manages the traffic as I just previously mentioned that. So how? By providing the load balance. So you might ask that we can have that is a service concept or the service kind which is used to implement the load balancer itself in the Kubernetes, right? But here, there we going to build or we going to make multiple container into one cluster to have a load balancer. But here, in those cases, we cannot able to provide security. We need to write another script for having the security. But when it comes to this concept, the load balancer, so we have a data planner, right, and the control planner. So the control planner will going to redirect so between the containers. So not we won't be having a single container having the sign up microservice running there. So one or two or three like that. So when there is a huge traffic, based on that, it will redirect the request among the available containers through sidecar proxies. Distributes the request across the service instance to optimize the resource utilization. So, for example, that all the requesters are intended for single container means obviously the container might delay in processing the request as all the requests are moving to that single particular container. So, on that case, it should be redirected to multiple container rights for that. And again, the routing as same, just I mentioned. So directs the traffic based on the rules. So we'll be defining the rules on CPU utilization to this one, kindly redirect to that another container which is already running. So enabling canary deploy. So this is the another feature or the tool or the methodology I can say that canary deployment model, that is A/B testing and blueprint deployment. We're going to see all these things in future, and we'll understand what is service discovery. We come across in previous two slides, right? So automatically identifies available services in the network and allowing them to communicate without hard coding the addresses. So what is the work of the service discovery here means? So assume that we have 250 containers running in my Kubernetes, and each containers have its own microservices running. So we will be having that one control node and the data node associated with the microservices, and the control node will going to manages all the traffic, right? So how will I control node knows that sign up container is running on this particular IP address and this login is running on this container and the payment checkout card catalogs and the products categories of products are in particular containers? How will the control plan will know? So either the developer or the DevOps engineer, one who deploys the microservices in the Kubernetes container, should associate and mention in the DNS, right? So this container will have this service which is running like that. It should be. So in case of pod crashes, so the new pod or the new container will be up. So on that time, the IP will be different to the previous one. Again, someone has to come and manages that addressing or the mapping. So it was quite difficult, right? So someone has to keep monitoring all the time. So in case of if they are off from the if they are away from the servers or the system, they won't be getting any accesses. On those cases, obviously the system will be down for unless until someone has to come and pay attention to that issues. To overcome all those things, we have a tool or the feature in Service Mesh called Service Discovery. So where it going to automatically detects any new microservices or the containers which is launched, and it will going to identify that and allow them to communicate with the other microservice without any additional coding. So it will be taken care. And we were speaking about some securities, right? Even that can be implemented using the mutual TLS, that is encrypts communications between the service. So how we going to implement? By using the sidecar service, ensuring the data privacy and integrity, and the access control. So policies can be implemented to restrict which service can be communicated with each other. So for example, so the payment service is nowhere related to communicate with sign up or sign in or search one. So why do we require payment? Only to get our payment to my account. That's it. So is it necessarily required to link with your sign in or the sign up or the card? Yes, we required it for card for calculation, but we don't require it for payment gateway, right? Like that. So we can able to restrict that services for communicating with other services, so that the more security will be provided, like that. Okay. Next is observability. So monitoring and logging. So someone has to monitor, like that. We need to configure the CloudWatch in Amazon, right? Like that. Here also we'll be having some feature, that is monitoring and logging. So collect the metrics and logs from the services. So it will going to monitor every millisecond. So what is happening, from where the request is coming from, where it is going back, and whether the request what they have intended it is responding back with the same one, like that. So making it easier to troubleshoot these issues. And tracing. So tracks request as they move through various services. So as I just mentioned it, each and every moment or the every event it is going to monitor. So once the sign up is done, from where it is going, it should be reached to our database. So then if someone has to try to log in, from where it should go, it will go to login microservices. From there it will go to database, and it will fetch, and it will validate, and it will throw back to us for authentication, like that, right? Providing the insights into performance and the bottlenecks, right? Next is resilience. So retrieve and the circuit breakers. So automatically retrieves fails request and prevents overwhelming the service that are struggling, right? And the timeouts, that is, so if you made some multiple attempts, for example, that in banking applications, so if you enter multiple wrong passwords, what it will going to say the same concept for security reasons. And the timeout. So for example, sometimes if you have multiple requests, so what the servers or the containers will going to do that. So we have multiple requests, we need to move on, since there is a huge latency, I should drop this, like that. So to avoid those things, we will be setting some time limits, and it will wait till the response comes in that durations. Okay, that is timeout sets limits to on how long to wait for a response before considering the request as a failed, right? And we'll come across another one thing. So benefits of using the service mesh. Okay, so decoupled communication, that is developer can focus on writing the logic rather than dealing with the interfaces of inter-service communication. So as I just previously mentioned two slides back, so having the benefit, right? So it's not required to write another script for communicating between the microservices. So everything will be taken care by the service mesh based on the service discovery as well as the control panel. Okay, so those will taken care instead of the developers who doesn't require to write an additional code to interact with each microservices. And enhanced security. So built-in security features reduce the risk of vulnerabilities and improved reliability. So resilience features helps to maintain service availability and improve user experience. Greater observability. So we'll be having the logs, and the health checks will be done frequently. And popular service mesh implementations tools. So we'll be having some tools which we use to achieve the service mesh. One is Istio, so one of the most widely used service mesh, offering the rich features for traffic management, security, and observability. Another one is Linker, focus on simplicity and performance, providing the core service mesh capabilities with a lightweight footprint. So another one is console, a service mesh solutions that also offer service discovery as well as the configuration capabilities. And in cloud, when it comes to that is in AWS itself, we will be having the app mesh, a fully managed service mesh for application running on the AWS. So it's going to provide only on the AWS platform. So, but they are not limited to only on the AWS things, but it's going to limit it to Kubernetes. Okay, so we'll try to understand by going through some scenario based so that we'll be get to know exactly what is and how it is. Okay, so we will have three different microservices running in two different containers. So one is product service, another one is card service, another one is order service. So manages products information, and the card service manages user shopping cards, and order service orders processing. So before service mesh, how it was? Direct communication. That is, each server directly calls another service API. That is, we saw in AWS resources, right? All services. That is, why do we require Lambda and why do we require API gateway? So based on the URL, it used to redirect from one to another function inside the API calls. Issues, developer needs to implement retries or timeouts and security manually. So we need to implement, right? So I just mentioned in API gateway, we need to embed the resources followed by the what method we will be using, everything, right? And each service must know the location, and that is what I just mentioned, the URL. So that should be mentioned. So where it is exactly. So I should mention. So if something was wrong, again I need to update that one. Okay, of the other services. So next is debugging communication issue. So if you find any issues, it's quite harder to debug since we have linked all the other microservices, right? So we should understand, so from where exactly it is getting and why it is getting. It's quite hard to think because there is no centralized logging or tracing. So in case of the service mesh, so okay, so each microservice is paired with the sidecar proxy as initially mentioned, that is using the Istio. They are using the tool Istio. So the architecture looks like this. So assume that inside the one pod, that is you have the container called product service followed by the product proxy. We will be having that proxy server. So if you want to communicate with product service, you need to communicate with product proxy. Product proxy will going to communicate thereafter product service. Same wise card service and card proxy, order service, order proxy. How the traffic is managed here, we'll see. So routing. So when a user add a product to their card, the card service can call the product service. So what it going to, the card service will going to interact with the product proxy. That is through its process. The service mesh can route traffic based on the predefined rules like direct 10% of request to the new version. That is canary deploy, as I just mentioned, right? We saw. We'll understand this canary deployment later, so you just ignore those things. So if you want to communicate with the product service directly, you want to send request from card service to product service. We will be sending card proxy to product proxy. The product proxy, what it going to do, it communicate with the product service and it will revert it back. So on that time, it's not necessary to have a communication between the order service unless until we. Okay, next is security. So MTLs, all communication between the services are encrypted. The proxies handles the TLS setup automatically. So the proxy itself provide the communication management and also the security thing and the balancing load. So developers don't have to code this in each services. It's not required to have another file. So only the containers, it's more than enough. So observability. So each proxy collects the metrics and the logs as I just mentioned, right? If there is a performance issue, you can view the metrics through the centralized dashboard provided by the service mesh, making it easier to trace where requests are slow. And resilience. If the card service fails to connect to product service, the proxy automatically redirects the request without needing the additional code in the card service. Fine. And how exactly it will be. user action. A user wants to view the cart their service. Cart service request. So cart service request calls the order service to retrieve the order details. From there, the service mesh action, how it is going to action. The card proxy, whatever the request they have made, handles the request and applies any defined retrieves or the timeout. The card proxy communicates securely with the order proxy using the security, whatever they have mentioned. And the response. The order proxy processes the request and the response is sent back to the proxy itself, not to the cart service directly. So whatever the communication is going to happen between the microservices are done through the proxy itself, no matter whether it is coming inside the Kubernetes or outside the Kubernetes. So this is just an introduction and the over complete overview of the service mesh concept. We'll going to see in future session. So how we going to implement and how we going to configure all these things. That is the implementation of Istio. That is the tool to implement microservices in the Kubernetes. We'll going to see. Thank you.